morning. Oh my gosh, it's 5:18 in the morning. It's August 3rd. I'm so excited to be with you kids. Oh, August 3rd. You're probably like, it's somewhere in November. We're about to have Thanksgiving. What are you talking about? Okay, there's my little dirty secret. I'm recording these in the summer for you all. www.nkinfinity.com. N stands for Newman, K stands for Krause. She's my partner in crime. You can always visit the website. Hey, I probably had that done today. That'd be awesome. And infinity is how long this video is going to take. Oh, I'm just kidding. Oh my gosh, Java, who cares? Today I will be called Mr. Key for you today. All of this material, or all these videos can be found at NK Infinity, as well as a means to get these documents if you are a teacher or a homeschooled teacher. But that's neither here nor there. Today we are going to talk about Unit 3-10. Oh, what are we talking about? Solving using the quadratic formula. Now, I believe you got exposed to this in 9th grade. And I'm not certain, but I believe you did. So let's see. Let's just get started. We're just going to solve quadratics. It just sounds like a lot of fun. You know I need my coffee. It's the first cup of the day. Man, stop yelling at me. Standard form just means we're going to have it in y equals ax squared plus bx plus c. Are there always going to be pluses? No, but you want the x squared first, the x squared term first, the x term second, and the constant at the end. So the only thing I need to do is move that over. So when I move that over, it just gets a sign change. It becomes x squared plus 2x minus 24. So there it is in standard form. Woo! When I put things in standard form, I need some coffee. I know you're probably thinking, boy, these videos could be like half as long if you didn't have any coffee. Are you kidding me? Have you ever seen me talk without coffee? It go like this. I talk really slow, so the video take really long, which is why I need coffee. All right, what are the A, B, and C values? Now, this is kind of tricky. Everybody wants to make A and B and C. You got to be careful. A is the number right sitting there. Oh, you don't see a number there? Oh, then A equals 1. B is the number in front there. B equals 2. C is the number right there. C equals negative 24. Okay, bring the sign with it. Whatever sign is in front of it gets with it. Now, if it's a plus, you don't need to put in plus 2 or plus 1. But if it's negative, you certainly have to bring the sign with it. Solve for all values of x when y is equal to 0. Well, in this particular case, we can just factor it. So what we have is x squared plus 2x minus 24, and they said y was equal to 0. So we'll just maintain that, and this, since it's factorable, makes our life a little bit easier. It's x plus 6, x minus 4. Those multiply to negative 24 and add up to positive 2. And staying with our simple terms, this is x equals negative 6, and x equals 4-bagger. There we go. We're done for the day. That's simple quadratics. Really, the only thing we talked about right now that's anything new, and not really necessarily new, but sort of review, is standard form and how to pluck off the ABC. Everything else we've done over the last couple of days. Do all quadratic equations have integer roots? No, clearly not. Most of them don't. Can all quadratics be factored? No, clearly not. I believe we've discussed completing the square, and now we're doing quadratic formula. So What are the two ways we have solved for quadratic equations so far? Completing the square and factor. Oh, let's see. Use completing the square to come up with a formula to solve for the proof of the quadratic formula. Oh my goodness. Hold on a second. Let's see if you remember the steps for the completed square. Isn't the first step bring the constant over to the other side? Oh, look, there it is. Constant's over on the other side. Then isn't the next step get rid of the leading coefficient, which is a, so we divide by a. So now I've divided by a. Now since a over a, that just gives me x squared, but I still have b over a. Isn't the next one take half of the middle term? And take half of the middle term. So here is the middle term. We're going to take half of it, which turns out to just be this, and square it and add it to both sides. So we added it to this side, and we added it to this side. Well, I'm not going through all of this because you're just sitting there going, woo, but this is all legitimately correct. And as a matter of fact, I will probably go over this in my classroom, but I'm not going to spend the time to do it here. If your teacher would like to or you want to go through it, you can. But lo and behold, when all is said and done, you get the quadratic formula. Now, I use this formula. I use this one in class. You know, most people, this is the one I like to use. Most people use this one. This one, the blue one, is the official quadratic formula in all of its glory. It's the way you're going to see it. I just like to split up the numerator because it usually makes things easier, especially when they ask you to put it in what's called a plus bi form, which is a complex number. Anyway, that's the proof of the quadratic formula right then and there. But I'm not going to go through it because it's all written out for you, and it's quite complicated. All right, so let's write down the quadratic formula. I believe this is on your formula sheet, so you don't have to have it memorized. I haven't seen that formula sheet in a while, but I'm pretty certain that it's on your formula sheet. But it's a good idea to get it memorized. It's not that hard. It's x equals negative b over 2a plus or minus the square root, oops-a-daisy, the square root of b squared minus 4ac all over 2a. Now again, most people will not split this up. Most people will just do this. They'll say this is the quadratic formula, which it officially is, and that's what you're going to see on your test. I like to just split up. I just like to split up the numerator as this. Just put them both over 2a. When you go, this is the work that I'm going to expect to see. I'm going to expect that you pluck off whatever A is you put there. You pluck off whatever B is you put there. You pluck off whatever C is you put there. And then they call this D thing. D, it just so happens, it's lucky it goes A, B, C, but it's capital D. D stands for discriminant. And the discriminant is the part that's under the radical. Now, the reason I ask you to do this first and outside is you'll make less mistakes if you do it outside. So we're going to say B, or D, is b squared minus 4ac. Okay? So remember, because some people have a hard time remembering, remember, these are all numbers. No x's. No x's. Okay? That's important because I still get people every year that want to put an x there for some reason. So here is a typical example of a function, of a quadratic parabola. Why am I not able to move? Come on. Quadratic. Okay, our first step is to get this thing in standard form and set it equal to 0. So we're going to do x squared plus 7x minus 6 equals 0. Now, I don't tell you when you need the quadratic formula, but every year, because, oh, it's 6 and it's 7, I'll get kids to do this. X and x. While I'm explaining this, let me get my calculator up. X and x, and we'll go, okay, 6 plus 1 is 7. It's got to be negative, so we'll just do, we'll do this. That's negative 6, and that's our answer. And then we get answers of x equals 1 and x equals negative 6. Or, they might switch them. Or they make them both positive and make both these negative or something. But no. Remember, if this is negative, if this number over here is negative, they have to add, they have to multiply to negative 6, but add to positive 7. So the only way to get a negative is if one of them's positive and one of them's negative. But these now aren't adding. Remember, we're not adding. This is positive 6 and negative 1. Those subtract to make 7. They don't add. Well, they subtract to make 5. They don't add up to 7. So be careful. Another great way to tell it is if you graph it, and you'll see over here. That's weird. You'll see over here that when you graph it, they don't seem to hit on nice numbers. Now, that doesn't necessarily mean it's not factorable. I mean, that could be, this could be 2/3, and then it certainly is factorable. So if I go into graph mode, and I type that in, x squared plus 7x minus 6, and I graph it, and I go, okay, menu 6, and we're looking for zeros, 1, and we get to the left side, and we click to the right side. Oh, man. Settings. It's not what I want. These silly things. Come on. 5. Someone changed my settings. No, that's on float. Why is it doing that? Menu. Is it going to go settings in here? Oh, settings. Here we go. Yeah, float 3. I don't want that. I want that on auto. Make default. Click OK. See, now you get this long 0.772002. You get this long decimal here. That's not going to be rational. So that means it's not going to be factorable. That means we're going to need our quadratic formula. So now we're going to bust it out. We're going to bust a move. So we write down A, B, C, capital D. Remember, capital D stands for B squared minus 4AC. We're going to do that work outside of the quadratic formula. Makes our life a little bit easier. Just a wee bit easier. All right. So A is 1. B is 7. And C is, don't forget to bring the sign with it, negative 6. So we're going to go, okay, B squared is 49. Don't write down 7 squared. I am telling you, if you do that and you try to use your calculator, half the time you will get it wrong. Write down 49. When we get to an example, which is the next one, I'll explain why. So we're going to write down 49 minus 4 times, write it out, 1 times negative 6. Doesn't take that long. Now this you can type into your calculator should you desire. It's just 49 plus 24, so that's just 73. But if you type in your calculator, you get 73. All right. Really, truthfully, that's all the hard work because you got the quadratic formula. You're already given that, so you just go, okay, x equals negative b. Well, what's negative b? That's negative 7 over 2 times 1 plus or minus the square root of 73. Notice I don't have to do any work. I've already done it. It's right here. I know that number goes underneath there, all over 2 times 1. So my answer is x equals negative 7 over 2 plus or minus the square root of 73 over 2. Boom. Chaka-laka-laka-laka. Well, let's see what it said. Solve and put the simplest radical form for the graphs on the right to system checking. So it did not say that we had to do anything other than that. So there we go. Sometimes they ask for the decimal, so you can come over here to your calculator and say, okay, I need a decimal. So then you say, okay, negative 7 divided by 2 plus the square root of 73, get out of the square root, divided by 2. And it's going to fix it, make it look all pretty for you. Look at how pretty that is. 0.772001. And the way to get the other one is just hit the up arrow. And you go back and want to retype all that. And you just change this to a minus, and you click OK. And those are the two x values. Those are the two roots, and they'll ask you to round them sometimes. Sometimes they ask you to round them. Now this one looks factorable. You see how it looks like it's hitting one root? So this one, to me, is probably factorable. Now I'm going to show you how you can tell if something's factorable. All right, write down A. Let's assume we didn't see that it was factorable. We didn't have a calculator when we just wanted to graph it. Or we just wanted to use the quadratic formula, because that's what we're doing. So A is 2. B is negative 8. And it's going to give me an opportunity to tell you about negatives. C is 8. And D is B squared minus 4AC. And now we're going to plug all those numbers in. Oops. All right, so let's plug these numbers in. Now, if I wrote down, now you're not going to do this. You're going to write down 64, because that's what negative 8 squared is. Negative 8 times negative 8 is 64. Minus 4 times 2 times 8. Now, I'm going to pretend like I did. Well, we're going to write that in. We're going to type that in. You should probably already see that. It's 64 minus 4 times 2 times 8, and we get 0. Now, watch what happens if I don't put in 64 and I do negative 8 squared minus 4 times 2 times 8. That is a dramatically different number. That's negative 128. Can't see it? Maybe I need to blow it up a little bit for you. That's negative 128. That is dramatically different. Now, the problem with it is this. When it sees this negative 8 squared here, it's doing 8 squared and tagging on the negative in the beginning. So if you don't put this in like this, you're going to get it wrong. Whenever this is 0, that means you're going to have one root. It bounces off the x-axis, one double root. In this case, it looks like it's just 2. But let's use the quadratic formula to see if we can get that 2. So it's x equals negative b. Negative b is 8 over 2 times a plus or minus the square root of 0 over 2 times a. Well, the square root of 0 is just 0, and 0, not 2 times 2. 0 over anything is just 0. So that goes away, and I end up with x equals 8 over 4, which is just 2. Ka-ching! All right. Do you remember me before telling you never, ever, 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 ever want to mess with an x squared that's negative? You just don't. Don't bother. Don't try it. It's just going to make life difficult for you. So we're going to move these over to that side. So I get x squared minus 2x equals, plus 5. So I move those over. And on the right side, or on the left side, I got 0. I just don't like having a negative x squared. In this case, it really wouldn't make any difference, but I just don't like it. Get in the habit of not doing it. A, B, C, and capital D. So let's see what we got here. A is 1. B is negative 2. C is 5. And D, which is B squared minus 4AC. Now let's talk about D real quick. Do you notice that over here I never hit the x-axis? When you never hit the x-axis, that means your roots are going to be imaginary. So let's see what that means as far as your discriminant. B squared is 4. That's negative 2 times negative 2. Minus 4 times 1 times 5. Well, if I put this in my calculator, I end up with negative 16. Did you notice that your discriminant is negative? This is also an indicator that you're going to have imaginary roots. All right, let's rock and roll. So we get x equals negative b is 2 over 2 times 1 plus or minus the square root of negative 16 all over 2 times 1. Well, we've already done this. We know what this is. The square root of negative 16 is just 4i. Remember, it's I. It has imaginary, right? So we'll replace that. We'll say, okay, x equals 2 over, let's see, this is 2 over 2 plus or minus 4i over 2. So my answers are x equals 1 plus or minus 2i. All right, yay! That was complicated. What the what? Oh. Let's talk about this one. After every problem, I save it. That way I don't get the sound and the video all messed up. So, all right. Wow, this one looks really complicated. I can't say that. Now, it looks to me like it might be factorable. Because I see, looks like a rational root here and I don't know about that one. That clearly doesn't go through negative 1. So it looks like negative 2 might be an answer, but I really can't be sure. Let's distribute. 7x squared plus 7x equals x squared minus 10x minus 10. Since I don't want to have a negative x squared, I'm going to bring everything over to the left side. So we're going to subtract x squared. We're going to add 10x. And we're going to add 10. And all that stuff goes. So I end up with 6x squared plus 17x, which plus 10 equals goose egg. All right, now we're ready for the quadratic formula. Now I could check to see if this is factorable, which it is, but who wants to factor that thing with a 6 and a 10? The quadratic formula always works, and it's pretty simple to use, so we might as well just try it. We could factor it, but the quadratic formula always works. Completing a square sometimes works. Factoring sometimes works. Quadratic formula always works. And so when you get a little bit older, you'll see most of the older kids are going to stick to the quadratic formula because it always works. 6, 17, 10, and then b squared minus 4c. I write it every time just to remind myself and drive it in my head. Oh yeah, that's the discriminant. So b squared, 17 squared is 289. Don't write 17 squared. Just if you don't know 17 squared is 289, which is most of the population, just write that. Minus 4 times 6 times 10. Let's see. This is 289 minus 120, which is 169. Now that's a perfect square. And since that's a perfect square, this thing is factorable. So if you get something that's perfect square, you know originally it was factorable, which also means our roots are going to be real and integer, well, rational. They're going to be rational. So, excuse me, not real, but rational. X equals negative b is negative 17 over 2 times 6 plus or minus the square root of 169 over 2 times 6. Now, the square root of 169, you have to simplify it as 13. So what I have here is x equals negative 17 over 12 plus or minus 13 over 12. And you're thinking to yourself, those are rational? Okay, you still have a little bit of work left to do. Since this can be simplified, you have to do it. Now, you can either go over to your calculator, wimp, and avoid doing fractions, wimpy, or you can just do it. So what we're going to do, we're going to do it. So we're going to do it. X equals negative 17 over 12 minus 13 over 12. Well, that's negative 30 over 12. Which is, let's see, what goes into both those? 6, negative 5 halves. Okay, I might have done some math wrong. Hold on just a second. My answer key and my work do not, let me make sure I got it. 17 squared minus 4 times 6. Oh, 4 times 6 times 10 is 240. But it's still a perfect square. Oh, man. How bad a math is that? I'm glad I checked my answer key. Jeez, I was just getting embarrassed. 240. It's only going to change it slightly. Don't worry about it. So this makes this 49. So up here, I'm going to go, okay, 49. Square root of 49. The square root of 49 is 7, so this is just 7. Sorry. Oh my gosh, I'm so embarrassed. So, negative 17 minus 7 is negative 24 over 12, which is negative 2. I knew I wasn't arriving at my two answers here, and I knew something was a little off. It clearly was me. So negative 2. And then x equals negative 17 over 12 plus 7 over 12. And this turns out to be negative 10 over 12, which is really just negative 5 over 6. So my two answers are negative 2 and negative 5 over 6. All right, every time I do a new problem, I stop for a second. Okay, again, what do we know? It's not hitting the x-axis. I mean, I should do this in different colors so it actually shows up. Look over here. Does this parabola hit the x-axis anywhere? Never. So if you get this, you know your roots are going to be imaginary. Which also means our discriminant is going to be negative. Anytime it doesn't hit the x-axis, our discriminant is going to be negative. So let's clean this thing up. We're going to bring everything to the right side, left side. So I get 4x squared minus 20x plus 25 equals 0. A equals B equals C equals capital D equals B squared minus 4AC. A is 4, B is negative 20, C is 25. So let's see what we got here. Negative 20 squared is 400. I'll try to get this one right for you. Minus 4 times 4 times 25. So let's see what we got here. 16 times 25 is... My graphs not match up? Some of my graphs got all messed up. Alright, so the graphs on this are backwards. They will be fixed. I'm going to assume... I'll tell you why in a second. I know this. I'm going to assume this graph goes with this one, and this graph goes with this one. So on yours, it probably looks right. So if I go back here and I look, do you see how it hits the x-axis once? Whenever that hits once, that means we have a double root. or the roots are equal. Well, if the roots are equal, I know the discriminant is equal to 0. So that's why I knew that this one didn't, because 400 minus, and if you do 4 times 4 times 25, you get 400. So this ends up being 400 minus 400, which is 0, which means I should be getting a double root or a bump off the axis. So my graphs got backwards. I'm not sure if that happened in the... Sometimes when I send it over to OneNote, things get a little bit crazy. It leaves off numbers. Sometimes it does some funky stuff. So I should have checked that. I apologize. I thought I did, but that I missed. So anyway, that gives us an opportunity to talk about graphs a little more. That was fun. So x equals negative b, which is 20, over 2 times a, which is 4, 2 times 4, plus or minus the square root of 0 over 2 times 4, but this stuff goes away. So what I end up with is x equals 20 over 8. If I reduce it, let's see, 4 goes into both. This is just 5 halves, which is really just 2.5. So my answer is 5 halves. And if I look over here, does that look like 2.5? Yeah, that looks like 2.5. All right, so finally, let's get to this one, and then I'll kind of summarize some things for you. A equals 2, B equals negative 6. Be careful with that. C equals 6, and capital D equals B squared minus 4AC. B squared is 36 minus 4 times 2 times 6. It's 8 times 6 is negative 48, so this becomes just negative 12. So we're going to have to do a little bit of work on this one, negative 12. This one's going to be probably the hardest one we're going to do so far. So let's go. X equals negative b is 6 over 2 times 2 plus or minus the square root of negative 12. We're going to have to work on that one, all over 2 times 2. Now I'm going to bring negative 12, square root of negative 12 right here. And I want to work on that. So I know that's equal to the square root of negative 4 times 3. And then I say, okay, the square root of negative 4 is really 2i. And we said whenever the graph doesn't hit it, our discriminant's going to be imaginary or negative, and we're going to have imaginary roots, which means we're going to have I in our answer. So anytime your graph does not hit the axis, you're going to have I in your answer. So don't make that silly mistake. So what we have here now is x equals 6 over 4 plus or minus 2i square roots of 3 over 4. Now this can be reduced, so this becomes x equals 3 over 2 plus or minus, let's see, that goes in there twice, so I square roots of 3 over 2. And so that's our answer. Now sometimes your teachers want you to write it out. You can write it out like this. I square roots of 3 over 2. Put it in curly brackets, make yourself look professional. All right, so what part of the formula determines the types of roots and solutions for the quadratic formula? And the thing that's going to tell you about this, and that's why I said I'm going to paraphrase. Wait, hold on, let me see if I got some time. Let me stop. I'll be right back. I got to take some coffee break anyway. Wait, no, Dunkin'. Love Dunkin' Donuts. So what part of the formula determines the types of roots or solutions for the quadratic formula? The thing that tells you about the roots is the discriminant. It's the capital D. It will tell you about the roots. So what does it tell you? If the discriminant is equal to 0, that tells you it's factorable. Factorable if you wanted it to be. But more importantly, it's going to tell you this. It's going to tell you that you have real roots. They are rational. Now by real, I mean not imaginary. So they're either going to be real or not imaginary. You're going to be taking the square root of something that you can take the square root of, or the square root of a negative number. So in this case, the discriminant is 0, so they're going to be real. They're going to be rational. Rational means it's going to be a nice number. If you put it in your calculator, it's going to be either a repeating decimal or a terminating decimal. And equal. Now equal, because we said it's going to be a double root. It's going to be a double root. If your d is less than 0, and this is the weird case, this is imaginary. Oh, the only thing you're going to remember about this one is it's imaginary roots. Your discriminant is going to be negative, and you're going to have imaginary roots. Now, the tricky case is when the discriminant is greater than 0. If the determinant or discriminant is greater than 0, you have two cases. Case 1, if it's a perfect square, then it was factorable and you could have factored it. But what I want you to remember is they're going to be real. No matter what, they're going to be real. But here's the kicker. They're going to be rational. They're going to be nice numbers. Basically, if you're saying, if I asked you what's the square root of 36, you'd say 6. That's a nice number. If I asked you what the square root of 7 was, you'd be like, 2 something? I don't know. Yeah, it's not a nice number. So when it's a perfect square, they're rational. Rational just means it's going to be a nice, what it means is it can be written as a fraction. It's a terminating or repeating decimal. But what I want you to remember, just for your own brain, rational just means, hey, that's a really nice number. 5 halves, 2.3. Those are rational numbers. And they are unequal. They're not the same. The only time they're equal roots is if you have the discriminants equal to 0. And then 2 is it's not a perfect square. And this isn't really going to change. They're going to be real. They're going to be unequal. But the only change is right here. It's not going to be rational. It's going to be irrational. Not a nice number. And, if you need to put numbers, perfect squares and not perfect squares. All right. So last page, we're just going to practice with that idea, and then we're done for the day. So determine the types of number of the roots each of the equations are going to have. So all we need to do is figure out A, B, C, D, and the discriminant. So we're just going to do the discriminant. Discriminant is equal to b squared minus 4ac. Now we could probably do this without writing down a, b, and c. Let's see. B squared is 36 minus 4 times 1 times 5. That's 36 minus 20, which is 16. All right, so it's greater than 0, and it's a perfect square. It's a nice number. Now, the reason it's because, remember, in our quadratic formula, it's x equals negative b over 2a. That's just a fraction. That's not a big deal. The big deal happens right here because you're taking the square root of d. If d is a nice number, you're going to end up with just another fraction. So that means you're going to have rational roots. So it's going to be real. The only time it's not real, by the way, is if it's negative. So real, rational, that's the kick one. That's the big one right here with this one. And unequal. Though that's what we're going to determine about our roots. If you want a picture of what this is going to do, it's probably going to hit the x-axis in 2 nice places. All right. D equals negative, or 6 squared, which is 36, minus 4 times 1 times 9. That's 36 minus 36, which is 0. So anytime it's 0, it's going to be real. It's going to be rational, because you can take the square root of 0, rational, and equal. And so here's the big change on this one. Here's the big thing about this one. Anytime the discriminant is 0, you're going to have equal roots. All right, keep going. D equals 36 minus 4 times 1 times 13. This is 36 minus 52, which is equal to, I believe, negative 16. So that means I don't care if that's a perfect square. I don't care. All I see is it's a negative, and that means my roots are going to be imaginary. And we're going to go back and draw a picture for each one of these in just a second. And finally, the last one, D equals B squared is 36. Oh, that sounds familiar. 4 times 1 times 4. So this turns out to be 36 minus 16, which is 20. I cannot take the square root of 20 nicely. It's a nice number, but when I try to take the square root of 20, does anybody know what it is? It's not, so it's irrational. So this is going to be real, irrational, and unequal. Remember, the only time they are equal is when it is equal to 0. All right, so let's get a quick picture of what each one of these looks like. So real, rational, and unequal. Let me put axes for all of these. All right, I've got axes for all of these now. I'm going to go back and draw. So let's draw it in blue. So whenever they are real and rational and unequals, they're going to hit at nice points. So you might get something like this. Goes through a nice point, goes through a nice point. If they are real, rational, and equal, it's going to be a bounce, maybe like this. It doesn't matter if it's going up, concave up, or concave down. It could be that one, or, it could be over here, and it could be this one. The key factor is it only hits the x-axis once, and that way you know the discriminant is equal to 0. Imaginary just means it's going to never hit the x-axis. It could be like this, or it could be something like this. It just never hits. Never hits. Maybe I should have written down these. Never hits. Hits once. I call it a bounce. I'm going to bounce off. And here it hits two nice places. Hits two nice places. Get used to what these graphs look like and what the discriminant is. Real, rational, and irrational. So it's going to hit twice. Hits twice, but not at nice places. Now you have to be careful with this one, because just because it hit in the middle here doesn't mean those aren't 0.5. That could be negative 2.5 and 1.5, and those would be rational numbers. So the hard one to determine by graph is whether or not they're irrational or rational. That you can tell that the discriminant is greater than 0, but you not necessarily can't tell if they're rational or irrational until you actually figure out what the discriminant is. Okay, get that stuff down, kids. We're done for the day. Oh my gosh, that was fun. Bye. Goodbye, Dunkin' Donuts coffee. Oh wait, you get to come with me. That's awesome. Bye. No, really, bye. No, really, go away. I'm tired of looking at you. It's just a camera. It's not really you.